Hello friends. So in the last video we are prepared numericals of chapter number 1 which are most useful for your next test. Now today we are going to discuss several numericals of chapter number 2. In which chapter number 2 we have numericals of frequency, energy, wavelength, Bohr's energy, Bohr's wavelength, radius, then after numericals on the base of quantum numbers also. So there are number of numericals having different types. So today we are going to discuss numericals of each methods. So I will like to write a question in a form of numerical. That our question is the wavelength range of visible spectrum. The wavelength range of visible spectrum extend from violet its wavelength is given in question 750 and 400 nanometer. This is 400 nanometer to red. It is 750 nanometer. Express this wavelength in frequencies. Express this wavelengths in frequencies. So this is the question. In a question we have to highlight which parameters are given. So here for the violet coloration the wavelength is given 400 nanometer. On the other hand for red coloration the wavelength is given 750 nanometers. So here they are given in a nanometers. So how can we convert into meter? So 1 nanometer is equals to 10 power to minus 9 meter. So on the base of this formula we can write that for number 1 for violet coloration, for violet color, what is the value, what is the equation of frequency? So we know that frequency nu is equals to C upon lambda. So frequency nu is equals to C upon lambda. Now the question is that what is C? Because the value of C is not given over here, but you have to remember it is a constant. What is the value of C? It is 3 into 10 power to 8 meter per second. So it is the distance traveled by light in 1 second. It is called as a C. So I will write it having a constant value 3 into 10 power to 8 meter per second. Now about lambda. For violet coloration the wavelength is 400 nanometer and we have to convert into meter. So I will write 400 into 10 power to minus 9 meter. So if you calculate this numerical with the help of calculator, you will get answer 7.5 into 10 power to 14 hertz. What is the unit of frequency? You have to follow your answer by its unit. So it is a hertz. So in a same manner, you can calculate for red coloration. So I will write for red coloration. Frequency nu is equals to C upon lambda. Now what is C? It is distance traveled by light in 1 second. So it is 3 into 10 power to 8 meter per second. Always remember it having constant value. Lambda for the red coloration 750 nanometer. So we can convert into meter. 750 into 10 power to minus 9 meter. So if you calculate this numerical with the help of calculator, you will get the answer 4.0 10 power to 14 hertz. So always my answer is followed by its unit. So each and every physical quantity having their definite formula and its unit. So this is the numerical which is helpful to calculate frequency on the base of wavelength. So such type of tricky question are given in your question paper. So our second numerical is regarding calculation of wave number. Wave number means nu bar and calculation of frequency. So the question is calculate number 1 wave number and number 2 frequency of yellow radiation with how many wavelength? Wavelength is 5800 angstrom wavelength. So this is the question. We have to calculate separately wave number as well as frequency. So we know that first of all we have to convert 500 angstrom into meter. So the relation is 1 angstrom is equals to 10 power to minus 10 meter. So first of all we will calculate wave numbers. So I will write the formula. Wave number, the symbol is nu bar, is equals to 1 upon lambda. So the value of lambda is 5800 into 10 power to minus 10 meter. So with the help of calculator, if you will calculate, you will get answer 1.72 into 10 power to 4 meter inverse. This is centimeter inverse, and for meter inverse 1.72 10 power to 6 meter inverse. So you will get two answers, either in meter or in centimeter. Suppose if you want to convert meter into centimeter, clearly divide the given amount with 100. So meter is divided by 100, it will give centimeter. So you are allowed to write either meter or centimeter. Now for the second one, for the frequency. So frequency having a formula, nu is equals to c by lambda. C, it is a distance travelled by light in 1 second having definite ratio 3 into 10 power to 8 meter per second. So 3 10 power to 8 meter per second upon lambda. It is given here 5800 angstrom, but I will convert into meters, so 10 power to 10 meter is written. So our answer is 5.17 10 power to 14. 5.17 10 power to 14. Unit is second inverse, because look here, meter is cancelled and second is in denominator. So if we will convert, it will become second inverse. So this type of numerical will helpful to calculate both wave number nu bar as well as frequency nu on the base of only given wavelength of particular radiation. So with the help of radiation you can calculate nu bar as well as nu. Suppose if you want to calculate energy, then you are also able to calculate energy. How? Energy E is equals to h nu. What is h? It is a Planck constant, 6.626 10 power to minus 34 joule per second. And here we get nu also. So if you want to calculate extra, I will write over here extra. Energy E is equals to h nu. So you can calculate energy with the help of this formula, because nu is 5.17 10 power to 14 second inverse, and h it is a Planck constant, value 6.626 10 power to minus 34 joule per second. So put down the value of h and multiply with nu, it will give energy for the yellow color radiation. So you can calculate three parameters with the given wavelength, nu bar, nu as well as energy E. Third numerical is about calculation of number of photon emitted. So for the number of photon emitted during a photoelectric effect, A particular formula is not given in textbook, but we have to apply our logic. How can we calculate number of photon should be emitted from the photoelectric effect? So on the base of that concept, we will calculate one more numerical. So numerical is 100-watt bulb emits. 100-watt bulb emits monochromatic light of wavelength. Monochromatic light of wavelength 400 nanometer. 400 nanometer. Calculate number of photon emitted per second by the bulb. Per second by the bulb. So this is the question. Now simple. It is very simple. Listen carefully. First new terminologies arise over here. What is monochromatic light? This is the question. So mono means single and chromatic means coloration. The light which appear as a single color means either blue, either red, either yellow, or whatever it may be. Monochromatic means a light which possesses only one type of coloration. It is called as a monochromatic light. So here the radiation in term of wavelength is given 400 nanometer, and the demanded question is calculate number of photon emitted per second by the bulb. So first of all, we have to focus on 100 watt. What is 100 watt? So 100 watt is a power of bulb. So I will write power of bulb, which is 100 watt. We can simply convert as a 100 joule per second, because this is a power of bulb, the unit watt and joule second having equivalent relation. So now we can calculate energy. So first of all I will write energy of monochromatic radiation. Energy E is equals to h nu, but we know that nu is equals to what? C by lambda. So for a reference I will write over here nu is equal to C by lambda. So I will put down the value of nu in this equation. So equation become E is equals to h C by lambda, where h is a Planck constant having a constant value 6.626 10 power to minus 34 joule second. C, distance traveled by light in 1 second means 3 into 10 power to 8 meter per second, and lambda it is given 400 nanometer. So simply we can convert into meter like 410 power to minus 9 meter. So I will write down the value h is equals to 6.626 10 power to minus 34 joule second into C, 3 into 10 power to 8 meter per second upon lambda, which is given 400 nanometer. So it is 410 power to minus 9 meter. So if we calculate the energy, it will give answer as a 4.96 10 power to minus 90. 4.96 10 power to minus 19 joule. So this is the energy. Now we are interested to find number of photon emitted per second. So what is our next step? So we will divide energy by 100. So I will write third step over here, number of photon emitted is equals to 100 upon E, means power upon energy. So what is the power? Here we have the given value 100 joule per second. So I will write 100 joule per second upon energy. Energy is given in joule. So 4.96 10 power to minus 19 joule. So here joule is cancelled, so we have unit second inverse which is remain at the end. So if we calculate, then we get answer as a 2.0 10 power to 20 second inverse. So this is our final answer. So step number first, simply you have to calculate power of bulb, means what is converted to joule per second. Second step, calculate energy, divide power with energy, you will get number of photon emitted during wavelength 400 nanometer and so on. This is and at the end we are going to discuss one theoretical topic, that is cathode ray tube. So in a cathode ray tube, earlier we discussed the experiment was performed by Michael Faraday. So when Michael Faraday performed electrolysis of electrolytic cell, if high voltage is applied at the both terminal, means both end of electrode, means cathode as well as anode, a charged particle is travel in form of stream of particle from cathode and move toward anode. So when they are strike on anode, on the side of anode phosphorescent screen zinc sulfide is coated. So when they are strike on anode, they are reflected. So on the base of this, we can give one conclusion that cathode ray tube are actually negative charge particle, means they are considered as an electron. So the construction is like this. This is vacuum tube, so I will write this is vacuum chamber. In a vacuum chamber, two metal plates are sealed. They are connected with external source, means we can say that battery. This is negative electrode, later we know it is cathode. This is positive electrode which is called as an anode. This is called as a battery. So when a fluorescent screen of zinc sulfide is coated at the end, so when high voltage is applied, a particle in form of stream of particle are connect over anode and they are strike on zinc sulfide screen. So that charged particle are at the end considered as an electron. So what are their characteristics? So number one, in absence of electric and magnetic field, they travel very straight, but in presence of electric and magnetic field, they are deflected. Later they are considered as a negative charge particle, means they are electrode. So this is a cathode ray tube experiment which is most important. Either the complete question should be asked like this, write not on cathode ray tube experiment, or only results are asked in question.